Hi viewers, this is Neela. Welcome back to my channel. In today's video, we'll see how to find square roots by prime factorization method. There are many other methods like long division method and repeated subtraction that we will cover later on. Today, we'll see how to solve square roots by prime factorization method. And we will cover few questions on nested square roots as well. And the end section is very interesting because you're going to solve few puzzles. Okay, so these three things I'm going to cover in this video. Let's begin. See, as the name suggests, prime factorization, it means you will break the given number into prime factors. So before starting that, let's understand what are prime numbers. See, prime numbers are those which are divisible by itself or by 1, or you can say they have only two factors. See, example, I think you all know 2 is a prime number because 2 is divisible by 1 and 2 is divisible by itself, so it has two factors. So, likewise, 3 is also a prime number, 7 is also a prime number, and 5 is also a prime number. So they all have only two factors. 3 has 1 and 3, likewise 5 has 1 and 5, and 7 has only two factors, 1 and 7. So there are many prime numbers. 1 is not a prime number because 1 has only one factor, that is 1, because it is divisible by only 1. So we don't say 1 is a prime number, it's not a prime number. So if any number is given to you, so what you will do, you will just break it into prime numbers. So we'll see one by one how to break a given number. Still, in the previous video, I already covered that 64 can be written as 8 multiplied by 8, or you can say 64 is a square number and the square root of 64 is 8. Now we'll see how to find square root of 64 through prime factorization method. Okay. Now we are finding the prime factors of 64. See, 64 is an even number because it is ending with an even digit 4. So it means all even numbers are divisible by 2. So you will divide 64 by 2. On dividing it by 2, you get 32 as the result. Now 32 is again divisible by 2. So let's divide it by 2. You will get 16 as the answer. 16 is again divisible. So you will keep dividing till you get all prime numbers, or you can say till the number is not divisible further. Now when you divide 16 by 2, you get 8 as the answer. Now further dividing 8 by 2, you get 4 as the answer. Now 4 is again divisible by 2 and you get 2 as the answer. Now, if you see now further, you can't divide 2 because it's a prime number and it is divisible by itself only. So all these are known as the prime factors of 64. So what is the next step? Next step is you write all these prime factors in the multiplication form. So 64 can be written as 2 multiplied by 2, 2 multiplied by 2. 6 times you will multiply by 2 because you got 6 times 2 here. Now the next step is very important. In this, you need to form the pairs of the similar numbers. See, 2 and 2 forms of one pair. Next, 2 and 2 will form another pair. And next, 2 and 2 will form the next pair. So once pairing is done, so it can be written as 64 can be written as 2 square multiplied by 2 square and then again multiply by 2 square. Now, if you see here, all these bases are 2 and exponents are 2. So, if you know the laws of exponent, bases can be multiplied. When you have same exponents, you can multiply the bases. So, if you see, all these are bases here. See, this 2 is a base, this 2 is a base, and this 2 is a base. All these three bases have common exponent. So, when the exponents are same, you can multiply the bases. So when you multiply the bases, it is 2 multiplied by 2 multiplied by 2 whole square. So this can be written as 8 square. So 64 is nothing but 8 multiplied by 8. So square root of 64 is 8. Okay. So the main step is first you break the given number into prime factors. After that you do the pairing of numbers, pairing of similar numbers, and then find the square root. Now let's find the square root of 900. See, 900 is ending with 0. So all numbers which gets end with 0, they all are divisible by 5. So we'll try dividing 900 by 5 first. So when you divide 900 by 5, you get 180 as the answer. Now 180 is again ending with 0. So you can divide it by 5 again. So when you divide it by 5, you get 36 as the answer. Now 3 and 6, this is divisible by 2. So when you divide it by 2, you get 18 as the answer. Again 18 is divisible by 2. You get 9. Now 9 is divisible by 3 and you get 3 as the answer. Now 3 is a prime number, so we will stop our division here. So what all factors we got here? See, we got 5 and 5, 2 and 2, 3 and 3. All I have marked here in blue. Now the next step is you write all these in the multiplication form. So 900 can be written as 5 into 5, 2 into 2 and 3 into 3. Now the next step is pairing, which is very important. Pairing you will do of similar factors. So 5 and 5 forms a pair, 2 and 2 forms a pair, and 3 and 3 forms a pair. It means 900 can be written as 5 square multiplied by 2 square multiplied by 3 square. Now since exponents are same, you see 5 has 2 exponent, 2 has 2 exponent, and 3 has 2 exponent. When the exponents are same, you can multiply the bases. After multiplying the bases, you get 30 squared. It means 900 can be written as 30 multiplied by 30. So the square root of 900 is 30. I hope it is clear to you. Now let's say the question given to you is 252 a perfect square? So this question can be done in many ways, but we will try with factorization method. So what we are going to do, we are going to make the prime factors of 252. Now 252 is an even number, so you can start from dividing it by 2. Once you divide it by 2, you get 126 as the answer. 126 is further divisible by 2. You get 63. 63 is divisible by 3. You get 21. 21 is again divisible by 3 and you get 7. Now if you see, you got all the prime numbers because 7 is not divisible by any other number. So you will stop your division here. Now what all prime factors you got here? It is 2 multiplied by 2, 3 and 3 and 1, 7. So next step, as I told you, you will write it in the multiplication form. So 252 can be written as 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 7. Now next step is important. You need to form the pairs. So 2 and 2 forms a pair and 3 and 3 forms a pair. But if you see 7 doesn't have a pair, it means 252 can be written as 2 square multiplied by 3 square multiplied by 7. So since 7 doesn't have a pair, so it is clear that 252 is not a square number. Okay, because 7 is alone here. If so one can ask you like by which number you should multiply 252 to get a perfect square. So if you want to make this number a perfect square, so by which whole number you can multiply? So you need to just make the pair of 7. So if I multiply this whole number by 7, this will also become 7 square. So what we will do, if you multiply 252 by 7, you will get 1764. Okay, 1764 is a perfect square because its factors are 2 square multiplied by 3 square multiplied by 7 square. 7 is not alone now. So 1764 is a square number. So it means if you multiply 252 by a whole number 7, you will get a perfect square which is 1764. So 1764 can be written as 2 square multiplied by 3 square multiplied by 7 square. So you can say 1764 is a perfect square, and when you find the square root, it will be 2 multiplied by 3 multiplied by 7, which is 42. So the square root of 1764 is 42. Now we'll see a few questions on nested square root. Now if you see, there are two square roots. Okay, so don't get scared. First of all, whenever you see nested square root, always follow the steps. Okay, then the sums will become very easy for you. See, whenever the nested square roots are given, so always try to first solve the inner one, right? Okay, so what we will do, we will leave the outer one as it is. Now we'll first solve the inner one. If you see inner, the first is 49. See, 49 we know it can be written as 7 multiplied by 7. Okay, now put plus sign as it is. Now 25 can be written as 5 multiplied by 5. Okay, now in the next step, you can directly write what is the square root. See, 7 and 7 forms a pair. So the square root of 7 multiplied by 7 is 7 only. Plus, similar way, 5 multiplied by 5 will give you square root as 5 only. Now, when you add 7 and 5, it is 12. Okay, now we will solve 12 by prime factorization method. See, 12 can be written as 4 multiplied by 3. Okay, now we are doing prime factorization, so we will further divide 4 into 2 multiply by 2 and then multiply by 3 as it is. Next step is again formation of pair. 2 and 2 forms a pair. So it means the square root of 4 is 2. So we will write 2 outside and inside only 3 is left. And how to solve square root of 3, that we will see later. So the solution of this question is 2 root 3. Okay, we'll find the value of x. Here also if you see in this question, double square roots are given. Okay, so see square root of x and then square root of x is given root 5. We need to find the value of x. Uh, See, when I'm writing square root of x, it means what is the power of x here? The power is 1 by 2. Or you can see the value of square root is 1 by 2. So I can write this question as square root of x and then the outer one I can write as 1 by 2. Similar way on the right hand side, root 5 can be written as 5 1 by 2. Now I want a value of x, so I can eliminate this 2. If I say by squaring on both the sides, so I will do squaring on both the sides. When I'm doing squaring, this and this 2 will get cancelled. So I will be left only with root x equals to. Again on the right hand side, this 2 and 2 will get cancelled. So I am left with 5. Now I'm looking for value of x. So here also on the left hand side, root x can be written as 1 by 2 equals to 5. Again, I want to eliminate this 2. So what I will do? Again, I will do squaring on both the sides. Okay. So the right on the left hand side, this 2 and 2 will get cancelled. So I will have only x. And on the right hand side, 5 square is 25. So what is the value of x? Value of x is 25. Now get ready for some interesting facts. So you must have heard the word, I think, palindrome in computer science. See, palindrome are the numbers or the words which reads the same, even though you reverse them. Okay, so that interesting. Let's find some interesting thing in square roots as well. So let's say the number is 121. We know that 121 is the square root of 11. So if you notice, 121 is also a palindrome and 11 is also a palindrome. There are many such numbers. See, try one more. See, 484. If 484 you can read, even though you reverse it, it will remain the same. And its square root is 22. So both 484 and 22 are palindrome. 10201, the square root is 101. Both are palindrome. So such interesting things are also there in square and square roots. And there are many such numbers like this in square and square roots. Now get ready to challenge yourself. It's a puzzle time now. Okay, read all the instructions carefully and then try to solve this puzzle. It's very interesting. See, it's a 3-digit perfect square because we are solving square root, so it's a perfect square. The second condition is if you reverse my digit, I'm still a perfect square. Okay, but there are no zeros in it because if you're thinking that this number is 100 or 900, so that is not the answer. And the last condition which is given to you is am not a palindrome because palindromes are the number which even though you reverse it that reads the same. So it is not a palindrome. Okay, so who am I? So try to crack this puzzle. It's very interesting. So you can revise your square roots as well by doing such puzzles and write to me in my comment section. Now see the next puzzle. Get ready to challenge your brain one more time because another puzzle is waiting for you. See, the second puzzle says, if you take square root of me and then add 5, you get the same result as if you had subtracted 1 from me. Okay, so try to solve these two puzzles. I can give you only one hint in this puzzle that it is a single digit number. So the answer is a single digit number. So I'm sure that you can crack both these puzzles and you can write to me in the comment section. Okay, in today's section, I only covered how to solve square roots by prime factorization method. In my future videos, I shall be covering how to find square roots by long division method and repeated subtraction. Thank you for watching this video.